Hello peeps, we are from group 9 and today we're gonna share with you about ocular irritation test, specifically isolated chicken eye test. So what are we waiting for? Let's go! Isolated chicken eye test is an in vitro investigation that focuses on assessing the isolated chicken eye to determine the irritation potential of household cleaning product. The purpose was to ensure the product are safe to be used. This test was introduced in 1993 as a modification for isolated rabbit eye test. It assessed the corneal damage and not conjunctival and iridial injuries as evaluated in Dre's eye test. Isolated chicken eye test involves a single application of test substances onto the cornea of chicken eyes. The endpoint of this test is corneal swelling, corneal opacity, and fluorescein retention. Isolated chicken eye test is basically free animal cruelty method. Although there is no control study about the optimum chicken age has been conducted, 7-week-old with body weight between 1.5 to 2.5 kg chicken was commonly used as the eye donor.
Now I'm going to talk about the procedures. So they are basically divided to two different parts: the preparation of the eyes and application of the test chemical. In the preparation of the eyes, of course we will have to dissect the chicken eyes from the skull. But before dissecting, we need to remove the eyelids carefully, taking care not to damage the cornea. Even excessive pressure will cause damage to the cornea. So the main thing we have to take note is we have to make sure that there is no damage of the cornea. This is really important because if the cornea is damaged, the chicken eye cannot be used in this test anymore. Once removed from the orbit, the eye is placed on an absorbent pad and all of the connective tissues have to be cut away, leaving the cornea only. The eye is mounted in a clamp with the cornea positioned vertically by exerting slight pressure to fix the eye properly. The clamp is then transferred to a chamber of the superfusion apparatus with temperature controlled at around 32 degrees Celsius. Then only isotonic saline drips are applied. They are then again examined with a slit lamp microscope to ensure that they have not been damaged during the dissection procedure. Cornea thickness should also be measured at this time at the corneal apex. The eyes with a fluorescein retention score of more than 0.5, corneal opacity of more than 0.5, or any additional signs of damage should be replaced. For eyes that are not rejected, the eyes with a cornea thickness deviating more than 10% from the mean value of all eyes are to be rejected also. So this is the diagram that shows the superfusion apparatus and eye clamps. When you want to apply the test chemicals, the eyes must be removed from the superfusion apparatus and placed in a horizontal position. Normally for liquid test chemicals, they are tested undiluted, but if dilution is needed, the preferred solvent is physiological saline. And we have to always make sure that the entire surface of the cornea is evenly covered with the test chemical. For solid test chemicals, it should be ground finely in mortar and pestle before applying. The test chemical is applied for 10 seconds and then rinsed from the eye with isotonic saline, approximately for 20 ml at ambient temperature. It is then returned to the superfusion apparatus in the original upright position. These control chemicals, either the positive one or the negative one, are to detect non-specific changes in the test system and to ensure that the assay conditions do not inappropriately result in an irritant response. Treated corneas are evaluated prior to treatment and at 30, 75, 120, 180 and 240 minutes after the post-treatment rinse. They are evaluated based on corneal opacity, swelling, fluorescein retention, and also morphological effects.
Now, I will be presenting about how the test result is interpreted. Firstly, corneal swelling. It is determined from corneal thickness measurement made with an optical pachymeter on a slit lamp microscope. It is expressed as a percentage and is calculated according to the formula stated. Next, corneal opacity. It is evaluated by using the area of the cornea that is most densely opacified or scoring according to the observation described in Table 1. Fluorescein retention. It is evaluated at 30-minute observation time point only according to the score shown in Table 2. The mean fluorescein retention value of all test eyes is then calculated for the 30 minutes observation time point and used to assign an ICE class for each test chemical. Take note that only fluorescein retention determined prior to treatment and 30 minutes after test chemical exposure. Lastly, morphological effects. It includes splitting of corneal epithelium, loosening of epithelium, roughening of the corneal surface, and sticking of the test chemical to the cornea. These findings can vary in severity and may occur simultaneously. The classification of these findings is subjective according to the interpretation of the investigator. For data evaluation, results from the evaluation should be evaluated separately to generate an ICE class for each endpoint. The ICE classes for each endpoint are then combined to predict the individual classification. For decision criteria, once each endpoint has been evaluated, ICE classes can be assigned based on a predetermined range. Interpretation of corneal swelling, opacity, and fluorescein retention using 4 ICE classes is done according to the scales shown below.
There are a lot of advantages of this test. Firstly, the chicken's eyes are very easy to obtain and they are also very similar to human eyes. Next, this test requires less time to be completed than the rabbit eye test and it does not require any higher cost too. The in vitro model based on human cells is expected to give a better range of responses to toxic injuries that occur in human eyes and skin compared to the graze eye test. For the last but not the least, this test also provides information on health hazard likely to arise from the exposure to test substances like liquid or solid by the application on the eyes of the chicken. Limitation of this test are this test can give false positive results for alcohol and ketones. Secondly, this test does not consider conjunctival and iridial injuries. Besides that, this test also does not allow for any assessment of systemic toxicity associated with ocular exposure. Lastly, qualitative assessment of the corneal opacity is needed as in the rabbit eye test, but in a larger amount.